Hi, my name is Nishikant Shore and I'm a recent graduate of Brown University. What you see here is my thesis project. So what I'll be talking about today is a thesis project in general. What I will start out with is a general overview of what that project is. So I'm trying to develop a lightweight, practical vehicle that is a hybrid of human and electric power to be used in urban areas and reduce carbon dioxide emissions in the city setting. These vehicles will be used in conjunction with some sort of vehicle share program to maximize efficiency. So, to start the overview of the system itself, this is the electrical system, I will show you the components involved. The central part of this electrical control system is an Arduino Mega microcontroller, which has a large number of both analog and digital inputs and outputs. The next part is a simple breadboard, which I use to handle the wiring of the system. And you can see in the middle of the breadboard is a simple push-button switch, which is used in this case as an emergency on-off switch to disable or enable the system. Essentially, the idea is that if the system is disabled, the motor cannot function. So this acts as a safety mechanism for the vehicle. Next up is the actual user interface of the setup. On top here we have two potentiometer knobs and informative LCD display. As you can see right now, the system is inactive, and in order to turn it on with the push button, the set speed, which is controlled by this right knob, must be set to 0. The left knob controls the contrast of the display, as I can show you right now. You can see the contrast increase and decrease as I play with this knob. And as I mentioned before, the other knob sets the desired speed, or in this case RPM, of the vehicle, and I'll show you that in action once I demonstrate the whole system together. So, the other parts of this system are an electronic speed control, which is hooked up to both a battery, which you can see here, and a very small motor, which, while not ideal for the final project, is sufficient for showing that the concept works. The speed control essentially is a conduit of power from the battery to the motor, with a connection to the Arduino serving to regulate that flow. Now, I have this motor here, which has several times the torque and wattage capacity of the motor I just showed you. This is what will be used in the final product, or at least the next phase. So, without further ado, I will demonstrate the system in action. So right now, the system, as you can see, is inactive, and the speed is set to 0, so I can go ahead and turn it on. So as I turn it on, you can see that there are two values shown on the LCD display. The set RPM, which is controlled by the right knob, and the actual RPM, which is measured from the bike's wheels via an infrared emitter and infrared detector. The idea is that the infrared emitter is on the hub of the wheel, and each time it goes around, it triggers a response in the infrared detector, which the Arduino picks up. From these pulses, the Arduino can calculate the actual RPM of the vehicle. And so now, the general concept here is to control the speed of the vehicle, or the output of the motor, by comparing the desired RPM with the actual RPM. When the set RPM is below that of the actual RPM, the motor will speed up. So now, the actual RPM is set at 114. I will increase the set RPM until it rises above that, and the motor begins to turn. Once the set RPM goes below that of the actual RPM, the motor slows back down again. And just to show that the actual RPM does work, I will slide this piece of cardboard back and forth to interrupt the beam between the emitter and detector, and you can see as I increase in speed, the actual RPM increases, and then when I started decreasing again, it goes back down. If I move the cardboard in at a rate of about once per second, the actual RPM should show around 60, which it's doing now. So that is the part of the system that is complete right now. The next stage of this phase 1 is to mount this control system on a regular consumer adult tricycle, along with a mechanical system which it controls. That mechanical system is composed of a differential, which sums power from the pedals and the motor, which I showed you previously. Once that prototype 1 is finished and we can show that the concept works well, the next step is phase 2, the custom design of a light vehicle with a custom chassis, a custom designed drivetrain system, and everything made so that the energy used in the vehicle is used as efficiently as possible. This includes adding a regenerative braking system to the vehicle, which has not been included in this prototype. So yeah, that is an overview of my project. I hope you enjoyed watching today, and let me know if you have any comments. Thanks. Bye.